The Mission Impossible Lab will be conducted next, and by way of introduction, you have some background information that I want to share with you with regard to marble and acid rain. The connection to your world has to do with the statues, if you've ever traveled to Europe and observed that the statues, especially in Europe where the Industrial Revolution and the pollution was high, the statues are worn down. And they're worn down because the amount of acid rain produced years ago was so high that the marble, which is a carbonate compound, calcium carbonate, reacted with the acid in the acid rain and it washed away the marble. So your lab will actually be, you will be given a solid unknown. It will be a white solid in every case, and your task will be to figure out the identity of your unknown by reacting it with hydrochloric acid. So what are the products formed? What type of reaction is this? Just pause for a minute, fill in the blanks that are on this page. Can you do it? How did you do? Carbon dioxide gas, when this double displacement reaction occurs, carbon dioxide and water were actually formed because the product of this double displacement reaction was actually H2CO3. The H2CO3 was formed and that decomposed to produce CO2 and water. Three different examples of the experiment are the reactions that occur with your unknown. If your unknown is potassium hydrogen carbonate, you'll get a different salt than if your unknown is, whoops, little dot here for my hydrate. If you're, oh wow, missing 2 as well in my subscript. All right, so if your unknown is sodium carbonate monohydrate, you get a different salt. And then finally, if your carbonate is strontium carbonate, you'll get a third salt. So by identifying the type of product formed and doing a calculation, you'll be able to predict the identity of your unknown. So let's go through a few of these. Again, remember, why are the products the way that they are initially? Products are the way that they are because of the charges of the ions. And again, what happens to carbonic acid? As soon as you add the acid to the carbonate, you'll see the bubbles forming, and you'll produce your H2O and the carbon dioxide gas. When they decompose. So, just review a few things. There's 3 problems that you'll need to calculate. Given the amount of strontium carbonate, how much strontium chloride is formed. Given the same amount of sodium carbonate monohydrate, how much sodium chloride is formed. And then finally, given the same amount of potassium hydrogen carbonate, how much KCl is formed. It's the same type of stoichiometry problem in every case. However, the given and want formulas are slightly different. So the technique will be the same, the numbers will be slightly different. By way of reminder, don't forget, when you're figuring out the molar mass of a hydrate, don't forget that you need to consider the mass of the entire hydrate, which includes water, remembering that that dot does not mean multiplied by for molar mass. Okay. Again, another reminder is when you're organizing and thinking about this lab, how do you know when to stop adding the hydrochloric acid? In other words, how do you know when the reaction has finished? So to review, before you come to lab tomorrow, you want to bring the following things, and you want to have done these on loose leaf or type them up would probably be even better if you know how to do that on using the equation editor on your computer. If not, loose leaf is fine for the number one. You're going to do the calculations for each unknown. You're going to, on the computer, prepare two data tables, one for me, one for you, and two procedures, one for me again, and one for you. Thinking about making the data table, you want to consider your procedure and the types of measurements you will be making. Lab is quantitative, so you'll be taking numerical measurements. You'll be using a balance. So it seems to make sense, instead of writing out the mass of beaker, the mass of, etc., just simply list the object, and under the heading of mass, you'll be able to fill in the values as you do the experiment. How many bits of data do you need? I don't know if you need all 5 of these. You might need less. You might need more. It kind of depends on your experiment. So again, make sure that you have that taken care of and ready before you come to class tomorrow for lab.